Hello people, welcome back to another low quality math video. Yay. Today we're going to be talking about right cylinders. So this is basically going to be a continuation of last time when we were talking about the areas of three-dimensional figures such as prisms. And cylinders are basically prisms with a circular base. So the cylinders we're going to be talking about today are right cylinders. Right cylinders, like right prisms, have two parallel congruent circle bases. So their bases are circles instead of polygons. So right cylinders, like right prisms, also have a lateral surface that's perpendicular to the bases. So right here, for example, I've colored the bases orange, and this is this lateral area right here, this white area, and it would be perpendicular to the base. And over here as well, let's say that this is the plane that contains the base, then this lateral area would be perpendicular to that base, and to this base as well. So let's move on to some of the formulas for finding the area of cylinders. So let's look at the net for a cylinder. So I made another model. I've colored the bases red and the lateral area blue. So as you can see, then the lateral area, if you look at down from a top-down view, just like prisms, it's basically wrapped around the perimeter of the base. So once again, just like prisms, the lateral area is basically a rectangle. And if I were to cut this open and show up the net, then it would look very similar to the net for something like a rectangular prism. So you can see that this lateral area is a rectangle, and it has a length that is equal to the circumference of the circle. So if I were to rewrap, then you would see that the length of this rectangle right here, the length of the rectangle is equal to the circumference of the circle because it wraps around like this. So this curved length is equal to the circumference of the circle. And then the width of the rectangle is equal to the height. So you can basically, to find the lateral area of the cylinder, you multiply the circumference of the circle, so 2 pi r. So this distance right here would be the radius, 2 pi r times the height. I'll model that over here. So right here, this distance from the center of the circle to a point on the edge would be the radius, and this distance right here would be the height. So to find the lateral area, you multiply 2 pi, the radius, times the height. And then that would get you the lateral area, which would be this blue area right here. If you wanted to find the surface area, you just need to add the lateral area to the area of the two bases. And since the two bases are circles, then you can use the formula for the area of the circle, which is pi r squared. You multiply that by 2 and you add it to the lateral area, which is 2 pi r times height. So that's a pretty easy concept. Let's do one practice problem, because most of these problems involve straight plugins. So let's look at this. So basically it gives us a cylinder, and it gives us a few dimensions, and we have to find the lateral and surface area. So lateral area, as we know, is 2 pi r height. So it gives us the diameter 6, so the radius would be half of that. The radius is 3, and the height is 12. So we just plug all of that straight into the calculator. I'm going to be rounding to the nearest hundredth, but if it asks for exact answers, you would leave it in terms of pi. And then we get that the lateral area is 226.19 square inches. And we know the surface area is just the area of the two bases plus this lateral area right here. So that would be 2 pi r squared plus our lateral area. And if we plug that in, we get our answer, which is 282.74 inches squared. So this is the total surface area, and this is the total lateral area. So cylinders, basically like prisms. Hope that didn't help.